Welcome, guys. Now that we have been able to fill up the Cayley table. So the only thing we have to do now is that we need to compare it with the results I have here. So it is clearly seen from here that we okay. So now look at this clearly. These are the results we have. Okay, for everything, and I noticed that each of the rows are complete for each of the set of elements. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. So there's no repeated value. So which shows that it's a group. It satisfies the associative property and every other stuff. But one thing you have to take note here is that this is the solution I have here, whereby f1 multiply f1 will give us f1. So instead of writing f, because there's no space in this box, that's why I wrote just 1. So I have 1, I have 1, correct. This is correct, and this is correct for everything. Now let's check. Diagonally, I have 1, 1, 1, 1. Can you see that? Complete. And at the same time, diagonally for f4, I have 4, 4, correct. 4, 4, 4. So that's correct. So what else do we have? I started with the third step, which is this picking this 4, which is this f4 that is there. F4, then I have f3, 4, 3, 2, which is correct. And at the same time, we have to pick this 2 that is there, f2. Then diagonally, we have 2, 5, 5, then 2, 1. Do you see that? Then for the row part, we have 2, 6, 6, then 3, 1. Do you see that? So and at the same time, we have the remaining one by playing the I try to play a Sudoku game in this case. So here I have 5 here. See the 5, that is correct. That's 6, 5, 4, 3, correct. I have 1, 6, 2, 4, correct. So if you try to compare everything is that it gives the correct, and this 4, 2, 6, 1, which is also correct, and 2, 3, 1, 5, which is also correct. So you can decide to leave your answer like this. You can try to do a rough sketching in a separate paper by using this pattern that I've done here, this shortcut. So then you can go ahead and interpret your final answer like this. But your final answer is not represented in this case. Instead of writing F1, you are supposed to write I in this case, identity element. All this F1 changes to identity element. F2 is 1, 2, F3 is 2, 3, then F4 is 3, 1, then F5 is 1, 2, 3. So like that. So then you fill this F4, replace it with what? With 3, 1, and this F3 replaces with 2, 3. So that's just what you are going to do. This thing is just trying to tell, this table is trying to show you that if you have F2 times F3, if I multiply this and this together, the result is F6. And this is F6 here, that's 132. If I try to multiply this F2 and F3 together, I will get F6. So that's just the best explanation I could give you based on this. So that's how it works, okay? So considering, okay, let me quickly make an example. Let me try an example. Let's confirm. So I want to pick if f3 multiply, let's say if f3 is 2, 2, 3. If f3 multiply f3 multiply f2, and f2 is 1, 2. So let's see whatever we are going to get. So here in this case, we are expected to have okay, the result. Let me put the result here. Now it is clearly seen here that if f3 multiply f2, the result gives f5, and f5 is 1, 2, 3. So let's confirm. Here in this case, if I start with this 2, or it is preferably you can start from this 1. So, but if I wanted to do it this way, okay, let's say we pick 2. So 2 goes to 3, right? 2 goes to 3. And here in this case, 3 goes nowhere, right? So then you write 3. So the next case is, now this 3 that you have here, 3 goes to 2. But here in this case, 2 goes to what? 1. Then you have what? 2, 2, 3, 1. So here in this case, if I decide to rearrange this result that I have here, the cyclic direction for this is 1 goes to 2, 2 goes to 3. That's 1, 2, 3. And the result is what? Is F5. And F5 is 1, 2, 3. So you see, that's how it works. So instead of you going through this stress one by one, so just use this shortcut. And similarly, if you have group of 4 elements, so you can also use any shortcut that you want. So that's how it works.